Welcome to Unit 8, Lesson 3 video. Today we're going to be talking about kites and trapezoids. We'll be using the properties from your property sheet to set up the problem, so you're going to need to be looking at that if you want to figure out how we're actually setting up the equations. But if we look at the first two, it's asking us to find EF, which is the mid-segment. Okay? And if you look on your property sheet, it tells us that we find the mid-segment. We find the mid-segment by adding the bases and dividing by 2. So AD is going to be base 1, BC is going to be base 2. So to solve for the mid-segment, to solve for x, we need to add them together, x plus 3 plus 12, base 1, base 2, and then divide by 2 in order to find the mid-segment. So the two bases added together divided by 2 is equal to the mid-segment. Okay? Now we got a big old fraction, so to get rid of it, to get rid of the 2 in the denominator, we need to multiply by 2 on both sides. That's going to give us x. I'm going to go ahead and combine the 3 and the 12. X plus 15 equals 6x. Okay? Subtract x from both sides. You get 15 equals 5x. So x is 3. But the question asks us to find EF. Okay. So for EF, we got 3x. So that's going to be 3 times 3. So EF equals 9. Over here, same thing. We got base 1. Down here we got base 2. So to solve for the mid-segment, we need to do the bases added together. So 4 plus 7x plus 4 divided by 2 is equal to the mid-segment. The mid-segment here is 3x plus 5. Again, we got a fraction with 2 in the denominator, so we have to multiply by 2. Have to multiply this whole thing by 2. I'm going to go ahead and add my like terms, 4 and 4. So we got 7x plus 8 equals, if we distribute, 2 times 3x is 6x. 2 times 5. That's a 2. 2 times 5 is 10. Okay. So now we can just solve minus 6x to make our lives easier. So we just have x plus 8 equals 10. We can minus 8 from both sides to get x by itself. So we got x equals 2. Okay. So just like before, we got to go back and plug x into the expression to actually find what EF equals. So we got 3 times x plus 5. We know we just found out that x is 2. So we got 3 times 2 plus 5, 6 plus 5. So EF equals 11. So the big takeaway here is that to find the mid-segment, you have to add the bases together to divide by 2, but also make sure you read the directions to see what you're actually finding. Some of them you're going to be finding the variables, some of them you're going to be finding the length of the segments. Okay. So that's it for mid-segment. If we scroll down, okay. Now we are talking about isosceles trapezoids, and we're finding the measures of the numbered angles. So if you look on your property sheet for isosceles trapezoids, we know 2 things. We know that base angles are congruent, and we know that some of the angles have to be supplementary. Okay? So first thing, we know that in the bottom right corner we have 49. That's a base angle. So if base angles are going to be congruent, that means this is the other base angle. So angle 1 has to be 49 also. Now the next thing we know is consecutive. So it's going to be 1 and 2 because they're next to each other. And because 2 is obviously not the same as 1, right? 2 is obtuse, I would say. And 1 is acute because we know that it's 49. So we know that 1 plus 2, angle 1 plus 2, has to equal 180. Okay? So we know that angle 1 is 49. So to find angle 2, we got to do 180 we got to do 180 minus 49, and that's going to tell us our base angle for number 2, which is going to be 131. So angle 2 is equal to 131. Now this is also a base, so 2 and 3 are the same base angles. So if angle 2 is 131, then angle 3 is going to have to be 131 as well, because they have to be the same. So we got 131, 131, 49. Now for the one over here, they turn the trapezoid sideways. It doesn't have the hash marks, but it tells us that they're isosceles trapezoids, so we can mark them if we wanted. Okay, so this is one base, so that means that angle 1 has to be 105 because we know that base angles are the same. And we also know that 105 plus angle 3 is going to have to be 180. Okay, so if we subtract 105 on both sides, we know that the measure of angle 3 has to be 75. So we got 75 here. And if angle 3 is 75, that means angle 2 has to also be 75. So that's how you find the angles of an isosceles trapezoid. If you scroll down, now we're talking about the diagonals. Okay. Now, one thing we know about the diagonals of an isosceles trapezoid is that they're congruent. That's one of the properties. So we're just going to set them equal to each other. So we got x plus 5, that's QS, is equal to 3x plus 3, that's RP. And then we can just solve. Minus x take away 3. So we got 2 equals 2x. 5 by 2. So 1 is equal to x. So for this one, we're done because it just says find the value of x. So we can stop right there. Okay. Now you guys can flip to the second page where we're going to be talking about another shape, kites. Okay. Now for kites, we know a couple things. First, if you look at the sides, instead of the sides that are opposite being congruent, the sides that are congruent are going to be right next to each other. So we got this and this are congruent if you look at the hash marks. And we got this and this are congruent if you look at the hash marks. Now the question here is not asking us about the sides. It says find the measure of the numbered angles. So we're going to be looking at the angles of a kite. Now one thing we know about a kite is that where the diagonals cross, it's perpendicular. So where these cross, these angles are all perpendicular, so they all equal 90. That means the measure of angle 1 has to be 90 degrees because it's a perpendicular cross. Okay. Now if that is 90, the other thing we know is that one of the diagonals bisects the angles in a kite. So if we look at this diagonal right here, this one clearly looks like it's cutting the angle at the top and the bottom in half. All right. So 45 is 1/2. That means that this has to be 45. So the measure of angle 3 is 45. Okay. Now I'm going to do some erasing to set up this next one. And so now we got to find the measure of angle 2. Okay. So if we look at this triangle, we know that this is 90, number 1 is 90, and we know that the angle up top is 45. So I'm going to draw that triangle. Then I'm going to move it. Okay. So we got this is angle 1, 90. We know that this up here is 45. Now to find angle 2, we can just use the triangle sum theorem. We know that all 3 of these angles have to equal 180. So we got 90 plus 45 plus whatever angle 2 is going to be equals 180. Right? And if you solve, you'll figure out that the measure of angle 2 also is 45. We have a 45, 45, 90 triangle here. Because this would only work if this was 45 also. 90 plus 45 plus 45 is 180. Okay, now if we look at the second one, angle 1, where the diagonals cross, we know it's going to be 90, because kites have perpendicular diagonals. They turned the kite for the second example, so the diagonal that's cutting the angles is actually going left to right now instead of up and down. So it's cutting these 2 angles in half. Okay. So that means if up top is 38, for number 3 is going to also have to be 38. Okay. Same thing for number 5. If up top is 53, that means at the bottom is also going to have to be 53. Now the key to finding angles 2 and 4 is using triangle sum theorem. So we have this triangle. We know that this is 90. This is 38. Okay. So we're trying to find the measure of angle 2. It's the missing angle. So 90 plus 38 is 128, but we got to get it to 180. So the only number that will work here is 52. So angle 2 has to be 52 degrees. And then we're going to do the same thing to find angle 4. So that's our triangle. Again, we know that this is 90. We know that this is 53. So to find the measure of angle 4, we're going to do 180 minus 90 minus 53. If we do that, we get 37. So the only way this triangle will work is if this was 37. Now, if we look at the third example, something is missing from the picture that was in the first 2, right? The first 2, I highlighted the diagonals. This one doesn't have any. So if we were going to find E and G, we will first need to know the measures for our triangle. So we need to cut this in half. We cut 120 in half. We know that this is going to be 60. We know that this is going to be 25. Okay. Now, we cut a kite in half. We get a triangle. We can move this triangle. Copy the numbers. We got 60 and 25, which is 85. Now, the only thing that will work for angle E 180 minus 85, that would be 95. And if you look, the triangle at the top is the same as the triangle at the bottom. They're going to have the same characteristics, same angles. This is 60. This is 25. This is G. So we know that angle G is also going to have to be 95. So that's how you're going to go about finding the missing angles in a kite. One of the last types of problems we need to look at is finding the sides of a kite. And if you look back at the first example we did for kites, I said that the sides that are next to each other are the same. So those two sides are going to be the same. And if we look at our last example, these two sides are going to be the same. If we go to our first example, these two sides are the same. So these two sides are the same. Now, since there's only one variable, we can use any pair of sides to find the answer. So we could either do 2x minus 5 equals x minus 1. Or we could do x plus 4 equals 4 times x minus 2. Because they're both equal to each other. Now I think the blue one is a little bit easier, so I'm going to solve that one to figure out what x is. So we got minus x on both sides. So that's x minus 5 equals negative 1. Now we got to add 5 to both sides to get x by itself. So we got x equals 4. So if we do the red one, the red sides, we should get the same thing because x is going to be 4 no matter what. So we would have x plus 4 equals 4x minus 8. Subtract x, subtract x. So we got 4 equals 3x minus 8. Add 8 to both sides to get the x's by itself. We have 12 equals 3x. And then finally we have to divide by 3. So we get 4 equals x. So this one has more steps, but you got the same answer. Now if we look at what we need to do, it says find the length of each side. Okay. So we're not done just because we found x. But now we know we can plug in 4 for x. So instead of x here, we can put 4 minus 1. So we know that this side has to be 3. Okay. Now if that side is 3, then the other blue side has to be 3 as well because they're the same. That's why they're both blue. Okay. Over on the red side, we can plug 4 in for x here. And that's easy. 4 plus 4 is 8. And we know if that side is 8, then this other red side down here has to be 8. So we got 3, 3, 8, and 8 for our sides. So that's the relationship of the sides of a kite. Last thing we're going to want to look at, a little review. Matching properties with their type of shape. So this first one, we didn't have space to write it in the box, but it's parallelogram for the first one. That's what this shape is supposed to be. Okay, so let's look at the property. Both pairs of opposite sides are parallel. Well, first shape is called a parallelogram, so that probably means that both pairs of opposite sides are parallel. Okay? Now, if something is true for a parallelogram, it's also true for a rectangle, a rhombus, and a square because they are all parallelograms. Okay? So if I mark it for a parallelogram, I have to mark it for rectangle, rhombus, and square. Now, look at the next property. Exactly one pair of opposite sides are parallel. That's true for a trapezoid. And if it's true for a trapezoid, it's true for an isosceles trapezoid. Diagonals are perpendicular. Well, we learned today that that's true for a kite because they cross at a 90. It's also true for a rhombus. Okay? Now, if it's true for a rhombus, it's true for one other shape, and that shape is going to be a square because a square is a rhombus. It's a type of rhombus. So if it's true for a rhombus, it's true for a square. Look at the next property. Diagonals are congruent. It's true for a rectangle. And if it's true for a rectangle, it's true for a square because a square is a kind of rectangle. Just like the last one with a rhombus. Okay? Diagonals are congruent is also true, we learned today, for an isosceles trapezoid. So those are all the shapes that we learned so far that have diagonals that are congruent. Last one, diagonals bisect each other. If you remember from the last lesson, it was true for a parallelogram. So if it's true for a parallelogram, it's true for a rectangle, a rhombus, and a square. So it's true for all of them. Those four. So again, if it's true for a parallelogram, it's true for a rectangle, rhombus, and square. If it's true for a rhombus or a rectangle, it's also true for a square because a square is a rhombus and a rectangle. And if it's true, and a trapezoid has one pair of opposite sides and that are parallel, and so does an isosceles trapezoid, just to recap. I'm going to actually do a separate video that has the problems worked out. This was all the notes, really. You guys were supposed to complete the rest of it. But I'm going to do a separate video that has some of that work on it, just so you guys can check yourself. So that's the end of this video. See you next time.